Hello student, good morning. And this topic is the last topic for your syllabus of module 4 of linear algebra and differential equation. So in this class we want to learn the application field of the differential equation. Here we use the concept of orthogonal trajectory. Before we define which is the meaning of orthogonal trajectory, here we plot a diagram for you for your clear concept regarding your clear concept. So here we consider an axis, two axes. Observe very carefully. This one is your x-axis, okay, and that is your y-axis. Clear? If we consider a curve, this is your curve. Say this is your curve. This one is your curve, and our goal is to find another curve which cut the given curve is at a 90-degree angle. So if we consider this one is your tangent, it make an angle, positive angle phi 1, and here it's the another tangent for the required curve which makes an angle phi 2, okay, with the positive x-axis. An angle between these two tangent is exactly 90 degree, exactly 90 degree, okay. So the external angle phi 2 should be equals to phi 1 plus 90 degree, okay. If we take 90 degree, if we take tangent in both the side, then the left hand side becomes tan phi 2. Left hand side becomes tan phi 2, and the right hand side becomes tan phi 1 plus 90 degree, okay, plus 90 degree. So this should be minus cot phi 1, because tan 90 plus of theta, that is minus cot theta. So if you represent the point of intersection of these two curves by the coordinate p comma x comma y, p x comma y, if it's your coordinate of point of intersection of these two curves, in that case what represent tan phi 2? If we represent a 90-degree curve which is known as the trajectory, here we write only tra means trajectory. I'm not mentioning the full term. its trajectory. Okay, trajectory, trajectories, trajectories, R-I-E, trajectory. Okay, then what is the meaning of trajectory? From this equation you can easily write tan phi 2, which is dy dx of the given curve, because we have already know that we haven't knowledge that tan theta represent the gradient of the curve, which is dy dx, represent by dy dx. So dy dx for trajectory, dy dx for trajectory equals to minus, what side should be dx dy, dx dy dx dy of the given curve, of the given of the given of the given curve. Oh, sorry, of the given curve. If we mention here of the given curve, the given curve. Now we explain the concept regarding trajectory. A set of family of curve is given. You have to find a set of family of curve, and this set of family of curve, that means the required curve, should cut the family of the given curve is orthogonal. Orthogonal means 90 degree. Then this family of curve which cut orthogonally of the given curve is known as the family of the trajectory of the given curve. Okay, so here we consider a particular for a single curve. If we consider this one is your curve, and a curve is cut with the given curve is 90 degree, in that case this curve is known as the trajectory of the given curve. And how can I find the trajectory? That should be explained in after few minutes. So here we design a diagram. First we take a tangent of the curve, and next you make a tangent with the given with the required trajectory. If it makes an angle phi 2 with the positive x-axis, and the curve, the tangent at the point of intersection makes an angle phi 1 with the positive x-axis, then the relation between the external angle of a triangle with the internal opposite to internal angle sum, here we use this relation phi 2, that should be equals to phi 1 plus 90 degree, because the point they are makes 90 degree angle. And here we take the tangent of here we take the tan of both the side, then tan it's become tan phi 2, and this becomes minus cot phi 1. So tan phi 2 is for the trajectory. So here we represent dy dx for the trajectory, and here we represent, because it's cot phi 1, so here we represent minus dx dy at for the curve C at the same point. That is the interrelation between the curve and the trajectory. And now we explain how can how can I find the trajectory of a family of curve, and what is the field of application. So here we give the original application or definition of the family of trajectory. The orthogonal trajectory is represented by the family of curve such that every member either family cut each member of the other family at a right angle. We have already mentioned this concept according to the geometrical structure are called the orthogonal trajectory. The concept of the orthogonal trajectory is wide used in the application of mathematical, especially in the field problem. In the field problem, when we study the field electrical engineer, electronics engineer, or other computer science engineer, when they study in field theory or other theory, in that case, they should use the orthogonal trajectory. For instance, in an electrical field, the path along which the current flows are the orthogonal trajectory or the equipotential curve and vice versa. This relation is the vice versa. If the curve flow the current and so on, and what should be the flowing flow of the curve which cut the given curve orthogonally. Exactly for that reason, we start the orthogonal trajectory chapter in your syllabus, and next we move the procedure to find the orthogonal trajectory. If you can recognize the geometrical structure of this problem, then you can easily understand the procedure to find the orthogonal trajectory of the given familiar curve. If we consider it's a two-dimensional, because it's a two-dimensional car, because there is an only one variable and one independent variable and one dependent variable. So the general form of the curve in the two-dimensional system is x, y, and c. If we consider c is the parameter, that means it's represent a family of curve where the different value of c gets the different curve with the same nature, and that is also mentioned in your class, which represent the arbitrary constant. And next one is you have to delete this curve, because when you find the differential equation of a family of curve, that means you have to eliminate your arbitrary parameter. Exactly for that reason, here we write, when we eliminating c from this equation, a new equation form without c is represent here. From this we can say that from its a differential equation of in the form is this, eliminating c from the given equation. Then how can I find the differential equation of the orthogonal trajectory? According to the geometrical concept we have already mentioned in the diagram, just when we start the lecture. And exactly for that reason, we just replace dy dx by minus dx dy. We have already mentioned that is the relation between the that is the relation between the tangent of the curve and tangent of the orthogonal trajectory, which is dy dx replaced by minus dx dy. So exactly for that reason, replace the differential equation dy dx by minus dx dy, so that the product of their slope at each point of intersection is -1, because we also know that if the two curve is perpendicular to each other, then m1 m2 equals to -1, where m1 represent the gradient of the first curve and m2 represent the gradient of the second curve. The product of two gradients should be -1. Exactly for that reason we replace dy dx by minus dx dy. That should represent the differential equation of the given of the required orthogonal trajectory. When we solve this differential equation of the orthogonal trajectory, replacing dy dx by minus dx dy, we get the solution of the family of the orthogonal trajectory. Okay, that is the procedure to find the orthogonal trajectory. In the next lecture, we'll move to understand. We'll try to understand using some example. Okay, happy learning and thank you for listening, and wait for the next lecture.